Okay, so question 1 compares del z, del x, and del z, del y. Okay, this one, the functions is defined implicitly because your left-hand side you have sin 3z, right-hand side you have 3z, and it's impossible to express, okay, impossible for you to express z, okay, as a title, as z is a function of x and y. Because we got the term sin 3z, this is we bring to the same side as left-hand side, this is minus 3z. Impossible to express it implicitly as z equal to a function of x and y. So we call this is an implicit equation of function. Then okay, to do the implicit differentiation, you have two techniques. One is using formula, another one, okay, you may direct differentiation, but I would suggest you use a formula, it will be easier. So I'm going to switch to a new document. So now you have in next case the functions here. Let's say is this is implicit function. You put function of f, x, y, z. Select everything. So equal to 3z, bring to left hand side. You have y exponent x minus 5 sin 3z, okay, minus 3z. Okay, and then you find fx. It's okay when you use a formula. If you use a formula, when you when you differentiate it, when you differentiate respect to x, y, and z, okay, y and z are constant. So here means you del x, y exponent x minus 5 sin 3z, okay, minus 3z. So okay, later on you differentiate each term. So you del x, y exponent x minus 5 sin 3z. Del x each term. Del x, y exponent x minus del x 5 sin 3z, okay, minus del x 3z. So when you del x, y and z are constant, so y is constant, so you factor out y for the first term, then you del x exponent x. So z is constant, so sin 3z is constant, you factor out sin 3z, and then you del x of 5 sin 3z total is constant, that's why in this term you get 0. Because when you del x, if you use a formula, this is using formula, when you find fx, actually y and z are constant, that's why 5 sin 3z are constant. Okay. So this term you get 0. Then del x 3z also you get 0. Then del x exponent x you get y exponent x. Then later on you find fy. Fy will be, then you del y, so we go to this step, del y exponent x minus del y 5 sin 3z, okay, minus del x, this is del y, del y 3z. So when del y exponent x is constant, so this one you will get exactly exponent x, factor the constant, and then you del y, then you get 1. When del y pi sin 3z constant, that's why this term is 0. Del y 3z also you get 0. So your fy is actually you get exponent x. Okay, and then to get your you have to get the fz. So fz is del z y exponent x minus del z pi sin 3z minus del z 3z. Okay. When del z x and y constant, so the first term you get 0. So del z pi sin 3z you get negative 15 cos 3z. Del z 3z you get negative 3. Okay, and then to get your del z del x, using formula will be a negative fx divided by fz. What is fx that we obtain? Y exponent x. So fx is y exponent x. Okay. Then your fz is you get negative, and then negative 15 cos 3z minus 3. This is a del z del x. And then del z del y. Del z del y will be negative fy divided fz. Negative, and then fy is exponent x. Xy is exponent x. Okay, divided by negative 15 cos 3z minus 3. Here, and we expand the negative to the denominator. So y exponent x divided by 15 cos 3z plus 3. So this one is exponent x divided by 15 cos 3z plus 3. Okay, the question asks you to propose a relationship so that propose a value of y that will produce del z del x equal to del z del y. Okay, in order your del z, okay, so when you compare this one, these two, in order del z del x equal to del z del y, okay, y must be equal to 1, okay, so that, because if y1, we have 1 exponent and denominator same, so that's your del z del x equal to del z del y. Okay, is it? Okay, any questions? This is using formula. Yeah, okay. There are two ways, either you're using formula or direct differentiation. Okay, I would suggest, okay, if the question didn't mention using which method, then you just use the formula, will be easier. Any questions or not?
No question.
No question. So question 2. Can you show or not this one? Find del z del x using the implicit formula. Find del z del y using implicit formula, and then multiply by x. Okay, del z del y multiplied by x. Del z del y multiplied by y. And then show that you can get it is equal to z minus 1 over z. 1 over z. So same thing. Now you have your implicit functions, your f, x, y, z, x squared plus y squared plus z squared minus 1 equal 1 bring to left side. Okay, so this will become functions. In equations, okay, you have equal left side, right side equal something. So this one is functions. So first step, you have to find del z del x. Before you find del z del x, you have to find fx. fx. Okay, fx is your del x each term. Del x, x squared plus y squared plus z squared minus 1. Okay, when you del x, y and z constant, so this case you get this is 2x. Then you find the fy, basically you del y, x squared plus y squared plus z squared minus 1. Then you get 2y. You may stop me if you got any question while I'm writing. Show me if you got any questions. You may stop me. So fz, del z, x squared plus y squared plus z squared minus 1. This one you get 2z. Okay, and then now you find your del z del x. So del z del x will be negative fx divide fz. So negative 2x divide 2z. So it's negative x over z. Then you find del z del y. Del z del y is negative fy divided by fz. So you have negative 2y divide 2z. So you get negative y over z. Okay, and then equation 1, x multiply del z del x, y multiply del z del y. Constant x del z del x plus y del z del y. Okay, you have x multiply negative x over z plus y multiply negative y over z. Then you have negative x squared minus y squared over z. Okay. Is equal to z minus 1 over z. From here, in the case you have here, this one, when you factor out negative, you got x squared plus y squared divided by z. Then from the implicit function, you can write x squared plus y squared equal to 1 minus z squared. So you substitute, okay, x squared is 1 minus z squared. You divide by z. Simplify here, negative, negative, this one you have 1 over z minus, this is z. Okay, first term, negative 1 over z, negative, negative, positive, z squared divided by z, which is z. So we get the answer negative 1 over z plus z, or z minus 1 over z. So, z minus 1 over z. So, question 2. Is it okay, question 2? Question 3. If y is differentiable functions, x of x such that y over y plus 2 plus exponent ln z equal to ln 3 times x plus 4 divided by square root x squared minus 16 through this one. So again, you need to find del z del x, del z del y. Before to find del z del x, okay, you have to define this function become implicit function. It finds your fx, okay, finds your fy, fz. Okay, this one, make it become implicit function. It's a function of f, x, y, z equal to y over y plus 2. Okay, exponent ln z is actually equal to z. You have, please take note, e ln fx. The answer is fx. So exponent ln z, okay, it just make you confused. Here is actually equal to, it is actually equal to fx. And then, so minus ln, okay, this ln you can simplify using the formula. First of all, ln 3x plus 4 is divided by square root x squared minus 16. So y over y plus 2 plus z minus, okay, ln you can simplify become ln 3 times x plus 4. Okay, division will become minus ln square root x squared minus 16. Okay, again, the square root is actually, you can simplify again this one, y over y plus 2 plus z, so minus ln 3 times x plus 4, so negative, negative, positive. Okay, square root is actually ln x squared minus 16 power half. Y over y plus 2 plus z minus ln 3 times x plus 4 plus half ln x squared minus 16. Okay, normally if you have the ln function, simplify it. Otherwise, you also can take, even though you can ddx ln u equal to 1 over u du dx. So in this case, your u is quotient function. So you need the quotient rule to do your du dx. Okay, but if you simplify ln, if you have ln, let's say m divided a divided b is ln a minus ln b. Ln ab will be ln a plus ln b. Okay, if you got ln a power n is n ln a. Okay. So all the base case that you learned in secondary school, please recall back. So after you simplify it, okay, using the logarithmic formula, it will be easier for you to do differentiations. Okay, so now you can do your fx. So when fx, the first, okay, the delta x, first term is all y, yeah? So it will be 0. Okay, this two term is 0. So minus delta x ln 3 times x plus 4, okay, plus half time delta x ln x squared minus 16. Okay, when delta x, y and z constant, So differential constant you have 0. Okay, and then to differentiate ln, dx ln u is 1 over u du dx. So delta x ln 3 times x plus 4. Okay, so this is actually your u. So 1 divided by 3 times x plus 4, and then you delta x, okay, 3x plus 4. The same thing with half. So this one will be 1 over x squared minus 16. So this will be the u. And then you delta x, the u, which is x squared minus 16. So delta x 3 times x plus 4, you have 3 delta x 3. So you got 3 over 3x plus 4. Delta x squared minus 16, you have 2x divided by 2 multiply x squared minus 16. Simplify it. 1 over x plus 4 plus x over x squared minus 16. So this is your fx. This one is negative. Here, minus here. Negative. Negative. So you have negative 1 over x plus 4 plus x over x squared minus 16. If you want to simplify further, this is x minus 4, x plus 4. X squared minus 16 is actually x minus 4, x minus 4. So if you want to combine these two terms, in the first term, I need to multiply x plus 4, and then I need to divide by x plus 4. Okay, because x squared minus 16 is actually equal to x plus 4 times x minus 4. So if I want to merge these two equals, two fractions become one fraction only. So I must have the same denominator. So lacking x plus 4. So if the denominator for the first term you multiply by x plus 4, you divide here by x plus 4, you have to multiply by x plus 4. So now you have minus a negative 1 time here. So minus x minus 4 plus x. Divide by x squared minus 16. That's why fx can be simplified to 4 over x squared minus 16. This is fx. Any question or not? And then you can find fy. Fy is just change delta x to delta y. fy. You just change this one fx here to fy at delta y. So fy, this will be delta y, this will be delta y, this will be delta y. Okay, when delta y over y plus 2. Okay, you need, for this term, you need to use the quotient rule. Okay, remember you ddx u over v, you will have v u prime minus u v prime divided by v squared. So remember the operator is delta y. So this is ddx. So your u prime will be delta y u, v prime will be delta y v. So put down v is actually y plus 2. And then delta y u, okay, delta y u which is y. So minus u which is y. And then you delta y v which is y plus 2. Divided by v squared which is y plus 2 squared. Okay, delta y z, this term is 0. Okay, when you delta y, this function of x, this is 0. Delta y function of x, this is 0. So it's only effect on the first term only. You simplify here. Delta y, you have 1. Delta 1. This is 2, like z. So you have y plus 2 minus y. Okay, delta y is 1, so this is y plus 2 squared. So the answer is 2 over y plus 2 squared. So this is f1. For fz, delta z y over y plus 2 plus delta z. This is delta z. So plus delta z z. Okay, minus delta z. Okay, ln 3 times x plus 4 plus half delta z ln x squared minus 16. Okay, when delta z, x and y are constant, so delta z, okay, the first term this is y, so delta z constant is 0, so you only have, okay, this is x, that's y. Okay, the first term 0, the third term 0, the fourth term 0, only the second term delta z, the answer is 1. Okay, you can find your del z, del x is negative fx divided fz. Negative fx. Negative of this answer, so it's negative 4, or you negative it become 4 over 16 minus x squared. Negative 4 over x squared minus 16. It becomes 4 divided by 16 minus x squared. And then del z, del y is negative fy over fz, because fz we have 1. So fy, this is fy 2 over y plus 2 squared. 2 over y plus 2 squared. And then for the question 1, prove that this one question 1 you to prove x squared minus 16 del z del x. So okay. This one I will change to the p. X squared minus 16 times del z del x. Okay. So x squared minus 16, we multiply del z del x plus y plus 2 squared multiply del z del y we have x squared minus 16 del z del x is here, which is negative 4 divided x squared minus 16 so y plus 2 squared multiply del z del y, which is 2 over y plus 2 squared. This y plus 2 squared and this y plus 2 squared, we have negative 4. Okay. Don't forget this one and miss out. Del z del y have negative, so this one you got negative. Here we got multiply with negative 2. So negative 4 minus 2, so total answer is negative 6. So proven. So proven x squared minus 16 del z del x plus y plus 2 squared del z del y. The answer is negative 6. Okay, so any questions here for question 3? No, question 4. Okay, question 4 is asking two techniques. One is direct differentiation, another one implicit differentiation. So again, first step, this one, find dy dx. Okay, because here only x and y, we want to find dy dx. In this case also, normally if we can get y is a function of x, we can express y equal to a function of x. But here, inside sin you have y, cos also got y, right hand side also y. So y is actually implicitly defined in the equation here. It's possible to express y as a title and we'll let the right hand side equal to a function of x. That's why you need to use implicit differentiation. Okay, and then first of all, they want two technique. One using direct differentiation. Okay, if direct differentiation means to find dy dx, you need to ddx each term. Then you ddx sin x plus y plus Then you ddx cos x plus y equal to you ddx y. ddx. So ddx sin, remember, ddx sin u, we have cos u du dx, where this is actually your u. This is actually your u. So you will get cos x plus y, and then ddx x plus 1. So again, the same thing, ddx cos will be negative. Then if you ddx cos u, ddx cos u, the answer is negative sin u du dx. That's why you get this is negative. So it's negative sin x plus y, and then you need to ddx x plus y. The right hand side ddx y is actually dy dx. Okay, and then later on, cos x plus y, ddx x will be 1. ddx y is your dy dx. So minus sin x plus y, ddx x is 1, and you expand in, you have plus minus is follow linearity property. ddx x is 1, ddx y you get dy dx, so this is 1 plus dy dx. So equal to dy dx. Okay, now we can expand. So you have cos x plus y minus sin x plus y. So this one we have plus dy dx. This term extend here. So dy dx multiplied by cos x plus y. For here, this one, this is minus sin x plus y. So equal to dy dx. Later on, we collect the dy dx term together. I bring this one. We collect to this side. This one here. Cos x plus y minus sin x plus y. So you have dy dx. Collect everything together. This is one time. This one bring to right side. This become minus cos x plus y. So this one bring to right side. This become positive sin x plus y. Now you want to find dy dx. So dy dx will be your cos x plus y minus sin x plus y divided by 1 minus cos x plus y plus sin x plus y. this is using direct differentiation. If you want to use the implicit, if you want to use an implicit differentiation formula, even though this is only function of x and y, right? Similarly, you can write f xy is actually sin x plus y plus cos x plus y minus y. And you find, so in this case, you just find fx, fy. Okay, fx is del x, each term, del x sin x plus y plus del x cos x plus y, okay, minus del x y. Okay, when you're using the formula, so for the fx here, y is constant. Y is constant. So del x sin x plus y, you have cos x plus y. And then you del x x plus y. So this one, del x cos x plus y, you have negative sin x plus y, and then you del x the x plus y. Okay, del xy is 0. Because when you're using formula, when you differentiate respect to x, y is constant. That's why del xy here is 0. But if you use direct differentiation formula here, because you want to find dy dx, right? That's why your ddxy cannot be, when the ddxy is not constant, because we want to find dy dx. If you when ddxy is 0, then you couldn't find dy dx. So there's a difference with direct differentiations and using formula. So that's why for fx you will get cos x plus y, and then when you del x, the answer here is 1. Del xy, this is 0. And minus sin x plus y, this one you get also 1 plus 0. Del x is 1, del xy is 0. That's why fx, you get the answer is cos x plus y minus sin x plus y. Similar pattern, cos x plus y minus sin x plus y. Okay. So fy. Okay, fy just change delta x to delta y, where x is constant now. So delta x sin x plus y plus delta y cos x plus y plus delta y y. Okay, delta y sin will be cos x plus y, and then your delta y x plus y. Using delta y sin u is cos u, you have to delta y the u. Okay, delta y cos is negative sin x plus y, and then you have to delta y x plus y. Okay, delta y is 1. So when you're using formula, when delta y x is constant, so here you got cos x plus y. Okay, delta y x will be 0. Delta y is 1. So this is minus sin x plus y. Delta y x is 0. Delta y is 1. This is plus 1. That's why we have the answer is cos x plus y minus sin x plus y plus 1. Okay, so this is your f1. You have only function of x and y, so you can find dy dx. your dy dx will be similar, is negative fx divided f1, because you have only function of two variables implicitly. So you find fx, fy. So dy dx is negative fx divided by fy. So fx cos x plus 1 is equal to negative cos x plus y minus sin x plus y. So divided by fy is here, which is cos x plus y minus sin x plus y plus 1. So if I multiply the negative to the denominator, I will get cos x plus y minus sin x plus y. So divided by, okay, this will be negative, this is positive, this is negative. It become this is positive here. Sin x plus y minus cos x plus y minus 1. Okay. Check with the direct differentiation formula. Positive, negative, negative. So this is negative. This is negative. So I have this mistake here. So whether you are follow or not, otherwise nobody tell me this is wrong. This part, this is negative, it's negative y. So delta y, y. Delta y, y. So this one is negative. This is negative, this is negative. So this is negative, this is negative. So this is negative 1, negative 1, negative 1, negative 1. Okay, later on, I like this. Okay, I expand. You can expand the negative either to numerator or denominator, because I want to get the same answer with what I obtained using direct differentiation, where the numerator is exactly the same. So I will multiply the negative to the denominator. And that's why negative multiply negative 1, this is positive. This is positive, this is negative. This one become positive, the constant become negative. So now, okay, this is obtained using direct differentiation. This is obtained using formula. Okay, the only difference you learn, okay, what you learn is like this now function of two variables, three variables. So it's actually you have implicit function of x, y, z. Then you can find fx and differentiate fx, y, z constant. So fy, okay, x and z constant, fz. Fz, x and y are constant. Then you can find del z, del x, which is negative fx over fz. Del z, del y is negative fy over fz. Okay. This one is only the different function of implicit function of x and y. So you can find dy dx. Dy dx will be a negative fx divided by fy. So any question here for question 4? Okay, are you all down or not? Or just log in, nobody there? Okay, question 5. Differentiation phi is only phi del z del x. Because z, in this case, we couldn't express as z equal to fxy. So this is an implicit function in terms of x, y, z, x, y, z. You can find del z, del x, and del z, del y, but this question just want del z, del x. Honestly, you just express your, to be not confused with the, okay, this is an explicit function. So the implicit function, I use a capital F, f, x, y, z. So make this one, originally this is equation, so make it become function by moving the right hand side term to left hand side. So the implicit function f, x, y, z, we have 2x squared z power 4 minus 5 ln x, y, z squared minus 4z. Okay, when you see logarithmic term, simplify it before you do the differentiations. We got 2x squared z power 4, so minus 5 bracket, this is multiply, so we break it become ln, addition of the addition, ln x plus ln y plus 2 ln z minus 4 z. Because ln x plus ln y plus ln z squared will become 2 ln z. That's the formula just now. Multiplication become addition, power bring in front. Ln a power n become n ln a. So now you can easily do your fx. So fx, delta x each term, where y and z are constant. So you delta x 2x squared z power 4, so minus 5 delta x, okay, ln x plus ln y plus 2 ln z, okay, minus delta x 4 z. When delta x, y and z are constant, so z power 4 constant, 2z power 4 is constant, you can factor out, become 2z power 4, and then you delta x, x squared. Okay, delta x ln x is 1 over x. Okay, delta it, and here because I'm lazy to write each time, so I'll just expand in. Delta x ln y 0. Delta x 2 ln z 0. When you delta x, y and z constant. So differentiate constant you have 0. So same thing, the last term here 0. So the answer you have 2z power 4. Delta x x squared you have 2x. So total is 4x z power 4. So this for your del fx. So it simplifies up this term. Here, 5 over x. So minus 5 over x. This is fx. Because you just want to find del z del x. So after 5 fx, no need to find fy. Just find fz. For fz, you delta z. Delta z 2x squared z power 4, okay, minus 5. Delta x change to delta z. So in this case, no need to waste of time to find fy. Because Fy is needed if you want to find del z, del y, but the equation didn't want del z, del y, we just want del z, del x. So just pair to find fx and fz. Just put down only the operator del x change to del z. So minus, this is del z for z. When del z 2x squared is constant, so you factor out 2x squared and then you del z power 4. So when del z x and y are constant, that's why del z ln x is 0, del x ln y is 0, del z 2 times ln z is 2 over z. So del z for z 4. So we got 2x squared, del z power 4, we have 4z cubed. So minus 5 times 2, so minus 10 over z minus 4. Simplify it, so we have 12. This one, 2 times 4, 8. 2 times 4 is 8x squared z cubed minus 10 over z minus 4. Hence your del z, del x. Del z, del x will be negative fx divided by fz. So we copy down the answer for fx for fz equal to 4xz power 4 minus 5 over x minus 5 over x. Divided by, okay, this is fz, which is 8x squared z cubed minus 10 over z minus 4. You may leave the answer this one, or you can multiply the answer either to your numerator or denominator, or leave it in this form. So is it okay? Any questions?
Yeah.
Question 6. So the same thing, this is also implicit function because we got z, left side, right side is sin phi z. Where you couldn't express z implicitly as z equal to function of fx1. So you need to find del z, del x, del z, del y either using implicit differentiation formula or you want to use direct differentiation. But I would suggest that you use the using formula will be easier. So first step, defines the implicit function f x y z. It becomes z minus sin phi z minus, bring to the left side, minus 3x squared y minus exponent 2y. It finds fx. In del x each term. So del x is z minus, this term will be 0. Del x sin phi z. So minus del x 3 x squared y. minus delta x exponent 2y. So when delta x, y and z are constant, that's why delta x z will be 0. Okay, delta x sin pi z will be 0. Okay, when you delta x, so y is constant, so 3y is constant, factor out 3y, and then you delta x squared. Okay, when you delta x, y is constant, that's why the last term is 0. Okay, that's why you have negative 3y, delta x squared is 2x. So negative 6xy. Okay, negative 6xy. Okay, depend on if you bring z, this one z is positive. If you bring z, if you keep sin, if you keep sin, mean this k, this one I write the implicit function as here, or another way, you may keep the z to the other side, then the function of fx, yz will become sin pi z is constant plus 3x squared y plus exponent 2y minus z. Okay. If you put it this way, then your fx will get positive 6xy. Then how you define your fx, yz? Then on which one that you collect together. Okay, and then after you get fx, then you get fy. Fy, similarly, all the delta x is changed to delta y. So delta y z minus delta y sin pi z minus delta y 3x squared y minus delta y exponent 2y. Okay, when delta y, x and z are constant, that's why delta y z will get 0. Okay, delta y sin pi z will be 0. Okay, when delta y x is constant, that's why 3x squared is constant. Factor out 3x squared, and then you delta y y. Okay, delta y exponent 2y, you get 2 exponent 2y. That's why you get this one is negative 3x squared. So delta y is 1. So minus 2 exponent 2y. Okay, and later on find this thing. Later on finds f set. F set, I just change the delta y to delta z. So this is f set. Become delta z, delta z, delta z. Okay, when delta z, you have 1. Okay, delta z sin pi z, you have pi cos phi z. Okay, delta z 3x squared y, you get 0. Because when delta z, x and y are constant, so differentiate constant, you have 0. Delta z exponent to y, this is function of y, that's why also get 0. That's why fz you get is 1 minus phi cos phi z. Later on, find del z del x. Del z del x will be negative fx divided f1. fx is negative 6xy. Negative 6x1. Fz is here 1 minus phi cos phi z. This is positive 6xy. Okay, now I multiply the negative with the numerator term, so become positive 6xy divided by 1 minus phi cos phi z. Okay, and del z del y is negative fy divided this is z. This is z. Fy Fy is negative 3x squared. Negative 3x squared minus 2 exponent 2y. So divided by fz, which is 1 minus phi cos phi z. If I expand the negative to numerator, so this is 3x squared plus 2 exponent 2y divided by 1 minus phi cos phi z. What is equation 1? So this one. One plus two. Prove this. Prove del z del x plus del z del y. Oh, you see, multiply phi cos phi z minus 1. You see the pattern. So we got this term is positive negative. Difference because the term this one phi cos phi z positive negative, so I have to cancel each other. I have to expand negative to denominator. If I expand to denominator, this term is negative, and I expand to here. So you have negative 1 plus. So this will become negative 1 plus. Okay, this one you still have negative 3x squared. This is negative. Because we want to cancel this term. But this is positive. Positive phi cos phi z minus 1. So they have to expand the negative to the denominator. So now it takes del z del x plus del z del y, and then multiply by phi cos phi z minus 1. So del z del x negative 6x1. Okay. So it becomes phi cos phi z minus 1. Okay. Del z del y is here. plus negative 3x squared negative 2 exponent 2y divided by is positive pi cos pi z minus 1. We have the same denominator and then multiply. Okay, multiply by pi cos pi z minus 1. So the denominator will be cancelled. So you get negative 6xy minus 3x squared minus 2 exponent 2y. Okay, combine these two. Pi cos pi z minus 1. Multiply pi cos pi z minus 1. Now, denominator cancel. That's why you get negative 6xy minus 3x squared minus 2 exponent 2y. Okay, so after you get it, it's proven. So it's proven. Okay, we get del z del x multiplied by pi cos pi z minus 1. Okay, you get negative 6xy minus 3x squared minus 2 exponent 2y. Okay, so this is for the implicit differentiation. Okay, so far any question or not that you want to ask? So like very good. So the test hope you can score 100%. Because no question at all. Okay, we finish the implicit differentiation. This one. This one I'm still compiling. This is okay for double integrations. We can look at question 1 first. Evaluate the double integral. Later on, after I compile the complete question, I will post to the author. We still got some time. We can try a few questions, and then next week we continue. Okay, this one will consist of the double integral using Cartesian coordinate. Later on, next Monday, we are going to go through the polar coordinate and one of the application for double integral. The mass, beside area, volume, mass, and then we are going to the space area for the double integration. So question 1, easy. This one just rectangular. Evaluate this double integral 8 minus x squared minus y squared dA, where the region R is actually x from negative 1 to 1, y from 0 to 2. This is rectangular. This is a double integration, sir. Okay, this rectangular region, if you don't draw the region also easy. So we just show dA using dy dx, we change to dx dy also same thing. You get the same answer. So reduce 8 minus x squared minus y squared Okay, dA, I will prefer dy dx. So y from 0 to 2, x from negative 1 to positive 1. Okay. So when you do double integrations, start from the inner integral. When you integrate respect to y, x is constant. That's why x minus x squared are constant. So integrate constant respect to y, you have a constant and 1. That's why you have this one, x minus x squared is a group of constants, so constant and 1. Of course, you can put 8y minus x squared 1. I group it together. Integrate y squared, we have y cubed over 3. Put out limit from 0 to 2. Then still got the x. So when you integrate respect to y, make sure when you substitute, make sure you substitute inside y. Substitute to y. When you substitute, lower limit, everything 0. So here you got 8 minus x squared. So this is substitute by 2. So 2 cubed will be 8 over 3. Okay, when you substitute y by 0, this term 0, this term 0. So total is 0. Dx. And then you can expand in, and then lastly integrate respect to x. So you have 16 minus 2x squared minus 8 over 3. Integrate respect to x. So you can simplify this thing first. So 16 minus 8 over 3. So this is 48 minus 8. So 40 over 3 minus 2x squared. Okay, so this step you may directly using the calculator, or you want to integrate manually. So if you integrate manually, this one we have 40 over 3 x minus 2 x cubed over 3. Substitute from negative 1 to 1. This is what if you want to do manually, but I would suggest that you can use your scientific calculator. Here, 40 over 3 and 1 minus 2 over 3 and 1. So deduct with the lower limit, which is x equal to negative 1. Negative 1, so minus 2, negative 1 over 3 divided by 3. So 40 over 3 minus 2/3, negative, negative, so plus 40 over 3. Okay, so this is negative, negative, positive, so this is negative. So means we have K.G.Tay minus 4, 76 over 3. So 76 over 3. So if we use we can use the calculator directly. in this step, you integrate 40 over 3. So minus 2 x squared. From negative 1 up to positive 1. So 76 over 3. Okay, and I'm going to show you can actually use your mathematical software to directly get your answer if you know the limit correctly. For example, you use the mapper software. Yes. Yes.
Dan kalau di manual dan kemudian panjat, ada tingkat mark.
No. Because we have limited mark for the question. Normally the marks given limit, and then okay. For like this one, because this one you have x and y, integrate respect to y, and this one you cannot use calculator. So this case we got the method marks here. And the last one, because we know scientific calculator can give you the answer directly. So the method here, no marks. Because you are not in the calculus subject, you're not in the engineering mathematics 1. If engineering mathematics 1, then you need to show. But in this is engineering mathematics 3, the purpose we want to test is actually whether you know how to put up the limit, or we give you the application. The question is in application whether you can form the integral correctly, evaluate it. So this part, if you do manual also, we'll just look at it, means the first case, there's no method marks here. You just give mark at the last answer. And you don't worry, this is not SPM or SPPM, because I am the lecturer who teach, I am the one who give you the marks. Okay, as I told you, there's no marks here, it's only the last mark at the answer. So you don't worry. This is not like in the KSPM. The one that teach you is your teacher, but here you have another teacher to mark your script. But here is not. In university, it's the same lecturer who teach and marks. So don't worry, just follow your lecturer. If I say, okay, you can use calculator, this part all can skip, you can directly give the answer. Okay. For the marks, I will give this part maybe up to here, and some of where you cannot use a calculator. So that one we have the methods marks. So that one we for the process that we know that we can get the answer from the calculator, so can be skipped. Okay, and now I'm going to show how you use a software. So to use a software, this is a mapper. So you are lucky, okay, during this pandemic time, you're using online, and I show you how to use the software. Then if you know how to put up the limit correctly, you can use the software to double check it whether you with it software you can directly give the last answer. Then you will know whether your answer is correct or not. In this case, substitute this one to 8 minus x minus 1 and we will do y and x. So x form uh, 0 to negative 1, 1. Sometimes this one, you know what is error? This is using command. So check with what we obtained just now. 76/3, right? Using method directly you get the answer. This one. Y and x. This is 0, this is 2. So this bit, this one. Sometimes cannot just redo again, or you just use a command. Because maybe here. Using this one, you can do your double integration and got the template for triple integration. If got errors here, this is using command INT stand for integration. Integrate 8 minus x squared minus y squared, where the 1 comma y from 0 up to 2. Okay, and then after this one is for the inner integral, comma. Okay, this is integrate respect to y. This one the outer integrate respect to x. Okay, or if you change to dx dy for here rectangular region, as what we learned it last night, you can just swap the limit because rectangular region. You can simply swap the limit, but not for non-rectangular region. So this is negative 1 up to 1. This is 0 to 2. So 76/3. So you can use the software to check your answer, to find the last answer. But if you use calculator, you can only evaluate the outers only. Inner you cannot, because you integrate respect to x, you have here y. So your scientific calculator cannot do. So you can only apply it, apply your scientific calculator at the last integral, this part. So you can skip all these steps straight away, give the answer 76/3. Question 1. Okay, question 2, determine too many parts, not enough memory. Okay, question 2 determines the double integral. Okay, and since you know, you can use K.Mapper to know the last answer. But in exam, don't give me the last answer only. The last answer, then you get only 1 mark. So this one, 0 to pi over 4 through x secant squared y dy dx. Okay, this is a direct question where you just need to evaluate it directly. So this is the lowest level of the multiple integration, because higher level, where it's normally application question, where you need to put out your integrand, you need to put out your limit correctly. Because you put out your integrand limit wrong, then the rest will be gone. So what we said, this type of question is a lowest level, and you just need to directly integrate, no need to worry about whether your limit correct or not. Okay, so we integrate respect to y, x is constant, okay, x is constant, and then integrate secant. Remember, you differentiate secant, differentiate tangent. In the x tangent x, you get secant squared x. And integration is actually inverse of your integration. But integration is inverse of differentiation. And when you integrate secant squared x dx, you get tangent x. Okay, so that's why this is constant. So you have a constant time. You factor out because 2x constant, and in multiplication form, factor out 2x, then integrate 0 to pi over 4 secant squared y dy dx. integrate secant, you get tangent. So this is tangent y. Limit of y from 0 up to pi over 4 and to x. Then put up the limit. So we have tangent pi over 4 minus tangent 0 in x. Tangent pi over 4, the answer is 1. Tangent 0 is 0. So means you just integrate 2x x. 2x dx. If you do it manually, this one you get x squared over 2 and 2 here cancel. So 1 to 3. So 9 minus 1, the answer is 8. You can check the answer using mapper. This is 2 times x times secant y in squared. So I put a black pen. Secant y squared dy dx. Y from 0 up to pi over 4. Pi from the variable. Yeah, under the pi over 4, and then x from 1 to 3. Okay. So method directly give the answer. This is 8. So but in exam, if we just give 8, 1 mark. Because you want it here, because you need this step. Let's say here where I will get the marks. This one. Okay. Integrate, correct. Here 1 mark, and then you substitute. Okay, up to here. You integrate correctly. 1. Substitute the upper limit, deduct your lower limit, and then simplify correctly. Here 1. Okay. And then as I said, this one you can use calculator. So this one normally no marks, straight away the answer marks there. Okay. So this one will be a bit longer. I think maybe question 3 will lead to next week. Okay, and I'm going to finalize and later on. Okay, once I finalize it, I will put out the question to author. So for today, we have finished the implicit differentiation. Cover up 2 questions for double integral. Okay, the rest of the question I will finalize everything and put up to author. So any question that you want to ask,